Now we will check our hoisting specific structures for their capacity. This will be the winch and erection hook. And in order to do this, we will analyze the tension in a single cable. So as you may remember from the anchor detail, the erection hook can be found here. And we don't have a photo of a winch here, but you can see in this figure 14.5, the loop of cable used by the winch to raise the cables during sag set. Now remember from our previous video, we calculated P max in a single cable. All we need to do is compare this to the 3-ton winch capacity and erection hook capacity. And because the factor of safety is already built into the winch rating, we do not need to apply one. So here the winch has a 3-ton rating, and unless otherwise specified, we'll assume a 3-ton winch. And that gives a maximum force of 29.4 kilonewtons. And like I said, because that factor of safety is built in, all we need to do is take the max tension capacity of the winch over the max tension in a single cable, and that just needs to be greater than or equal to 1. Now, erection hooks are bent rebar pieces used by the winch while hoisting cables and setting sag. They directly relate to the single cable forces from the hoisting analysis because they are another point of failure for the winching process. We use a factor of safety of 3 here because this is a very dangerous process. And note, we don't use a factor of safety with the winch because that's built into the product. Erection hooks, like I said before, can be seen in the anchor details and the construction manual figure 14.5 shown above. This is also a pretty simple calculation. So to find the tension capacity of our erection hook, we use 2 times the area of the bar times the yield stress of reinforcing bar, where the bar area is used for a number 5 bar, and the rebar strength is 275 megapascals. Using this calculation, we can calculate the factor of safety for an erection hook, which we have here. In summary, we'll want to check our anchor sliding and uplift. So we'll want to check our anchor. We'll want to check our winch. And we'll want to check our erection hooks. And that will give us the minimum sag value or the maximum amount we can raise our cables for construction sag above our hoisting sag. And the minimum of these will govern, but that won't necessarily be the case for every bridge, as the geometry of the abutment can change. And for example, the anchor analysis can become the point that governs over the winch capacity or the erection hooks.